I'm going to start a new session. And so let's do a different one. Let's do, how about, this one's my favorite actually. Or no, I won't do that. That's a harder one. Let's do an easier one first. How about H2SO4 plus NaOH? Okay. So the first thing I want to do is write ions. These are crossing. They're both given to me as aqueous. They're reactants. So I can break them apart. How will these break apart? How will this one break apart? Anybody know how this one breaks apart? Let's see. I don't know what caret means. Okay, someone said 2H plus. Yeah, so when an acid dissociates, it dissociates into H plus other stuff, and there's two of them. This is what they call a diprotic acid. SO4 2 minus. And then this one hopefully is pretty easy. Sodium hydroxide is going to break apart into metal ion and hydroxide. And that just happens to be plus, whoops, hydroxide's a minus. Hello, okay. All right, so that's the first step. The second step is make new formulas, right? So who's going to go with who? I'm going to have, well, gosh, I'm going to have, let's use a different color. I'm going to have hydrogen ion go with hydroxide, right? Cation positive with anion negative, and sodium with sulfate. Cation positive with anion negative. How will hydrogen ion and hydroxide go together? What's the new formula?
They make H2O?
Yeah, and that's always going to be the case. So what I don't want to see people do is they say, oh, there's two hydrogen ions, it's H2OH or something like that. It's always going to, so ignore the coefficients. It's always going to go together with the charges. I just see that error so often, and I just want to be just really cautious with you guys. Cuidado with that, right? Only balance the charges. Don't worry about the coefficients. Okay, also, keeping that in mind, how will sodium and sulfate go together?
NaSO4.
Well, wait a minute. It's +1 and -2.
So 2 NAs.
Good. And it's got to go metal first, so it's Na2SO4. Okay, so those were the hardest steps. Now for step 3 is balance. So now I'm going to write the whole thing. H2SO4. Let's not worry about the states yet. Let's just balance. Plus NaOH goes to H2O plus Na2SO4. Okay. So what happens? Let's see. Let's look at metals. I got 2 sodium and 1. So I better do what?
Add a 2 in front of the NaOH.
Absolutely. Absolutely. Okay. And now we have hydrogen, oxygen, and sulfur. So actually sulfate's unchanged. So I can count sulfates. How many sulfates do I have on each side?
1.
1. So sulfate's fine. So let's go to hydrogen. Aha. How many hydrogens are over here?
There's 2.
Okay, good. How many hydrogens are over here?
3.
Well,
oh, no, 4. Sorry.
It's okay. This is why we're practicing. It's good. I'm glad you said 3 because someone else said 3. How many hydrogens are here total then?
There's 4.
Good. There's 4 here because there's 2 times 1 plus 2 times 1. Okay, so 4 and 2. So how do I fix it?
Need to add 2 in front of the, yeah.
Perfect. Yes. And so now I have 4 hydrogens, and then oxygen. So actually the sulfate oxygens have already been counted, 4 and 4. Over here I have 2 oxygens, and here I have 2 oxygens. So this is balanced. So the next thing is states. Let's find the states. So again, Let me do states in green. Maybe is green okay, or is that too? Can you guys see green, or is that not, maybe don't do that? How about
Yeah, it's hard to see.
How about I'll do pencil? I don't know. I'll just keep it. Okay, so the states. So these were both aqueous. They were given to us as aqueous. What about that one? I'm going to look that one up on a table. And the table will say sulfate is usually aqueous unless it's with calcium, barium. But what about sodium? Sodium's always soluble. So this one is actually aqueous. Okay, so let's just, all right. What about water?
It's a liquid.
Liquid. Okay, so we finished step 4, right? So step 1 was ions. Step 2, make new formulas. Step 3, balance. Step 4, states. Okay, so step 5, total ionic. Let's bring that up. Okay, so what I'm going to do, this one's aqueous, so I'm going to write it as ions. Let me drop down. I'm going to need some room anyway. 2 hydrogen ions, just like what we did up here, actually. This one's one. I'm going to have two hydroxides, sodium hydroxides, though. But so 2H plus SO4, 2 minus, aqueous, because that's aqueous. So all the ions are aqueous. So again, as a compound not showing charges, as separate ions need to show charges. Okay. Aqueous, aqueous. Now I have 2 sodium hydroxides. So that's going to be 2 sodium ions, aqueous, 2 hydroxide, aqueous. Okay, so that's everything on the reactant side. Goes to, now the water liquid stays as is. 2 water liquid. I can't break that apart. Finally, sodium sulfate is aqueous. So I can write that as 2 sodium ions aqueous. Let's move that over. Plus SO4 2 minus aqueous. Okay.
I have a quick question. It's
Go.
a little bit unrelated to this,
Okay.
but I was wondering when we're gonna turn in our test corrections.
So that I'm actually thinking about just curving it at this point, and because
Awesome.
it actually seems to be really difficult to do in this online environment.
Because
so I might just end up.
some of us already completed it, and I was just wondering if you still wanted us to turn
Oh,
it in.
you did the test corrections?
Yes.
But how did you
when
know
you
what you
gave
got
us-
wrong?
Huh?
How
I did
you
my
know?
text corrections too because
Yeah.
I just went over it with my team. Pretty much
Yeah, we met up with our lab groups and we did the test corrections all
Okay.
together before we were.
Let's talk about this when we're done with the lecture, and I'll go through that real quick. Then what,
All right.
maybe okay, maybe I'll so you guys found that valuable then to do.
Yeah.
No, yes?
yes.
Okay. Let me think about it afterwards, but let's continue with what we're doing. I know a lot of people are thinking about that, and I've been kind of fretting about it, losing sleep. So we'll talk about it definitely afterwards.
All
But
right.
let's stay where we're at. So now we want to, step 6, cancel spectator ions. So what cancels here? Goes away. What's aqueous on both sides? Okay, someone said SO4, absolutely, gone.
2 NH, the NH.
Na, sodium, 2 sodiums. Okay, so let me rewrite this so we can look at it. I have 2H plus aqueous plus 2OH minus aqueous goes to 2 water liquid. Do you guys notice something about this step? This step is basically denominator. Do I have a common denominator?
2.
2.
2H.
So I'm going to divide out that 2 also. By the way, you got to do that when you got to make that little cross them out. It's very satisfying. Okay, so then the net is what's left. When a hydrogen ion finds a hydroxide ion, aqueous, aqueous, in solution, they form water liquid. And this is actually, if you guys want a little hint, this is always going to happen with an acid plus a base. Now, what could also happen with an acid in a base, let me go back up for a sec, is I got lucky that the sodium sulfate was aqueous, but technically I could also get a precipitate. That could happen. That's more complicated. We could do that in a sec. But actually what I'd like to do next is go through the gas forming. Is that okay? Should we do a gas forming reaction? Are you guys on board for that?
Sounds good.
It's the one gas forming reaction that I would like you to know. And it looks like we have a good sized class now. I got 42 people. So you guys are hanging with me here. So I'm impressed. Okay. So the next one, let's take a metal carbonate. How about sodium carbonate plus HCl. Okay, this is perhaps one of the harder ones because there's a little bit of extra rewriting. So this is my gas forming reaction, and so there's a little side step with it. But let's write it as ions. So again, I have these are aqueous. Sodium's always soluble. Acids are always soluble. So I can write this as 2 sodium pluses, and carbonate is 2 minus. And the HCl will break apart into hydrogen ion and chloride ion. So then I'm going to switch partners. Who's going to go with who after they switch? So it looks like chloride will go with sodium and hydrogen ion with carbonate. So what are the new products then? I have sodium's plus, forget the coefficient, sodium's +1, chloride's -1, so I'm going to have sodium chloride. How will these guys go together? Anybody? Good. Someone wrote H2CO3. That's perfectly correct. I'm going to need 2 hydrogen ions. It's the cation, so it has to go on the left. H2CO3. Okay. So then the next step is to balance. Sodium carbonate, let's forget the states for now, plus HCl goes to NaCl. Oh, that's Na2. Excuse me. That's going to make it funny. Plus H2CO3. Okay, so right away, metals. There's 2 sodiums there and 1 there. So I'm going to have to put a 2 here, which changes the number of chlorides to 2. So now I'm going to have to put a 2 here, which gives me 2 hydrogens, which, oh, I have 2 hydrogens. How nice. So this is actually balanced. Let's find the states. Well, actually, so there's a special case here. This is the thing to memorize. So when I form H2CO3, H2CO3 decomposes. So this reaction is actually correct. I'm going to form sodium chloride and carbonic acid. But a billionth of a second later, the carbonic acid is going to go to H2O liquid plus CO2 gas. This is a special reaction. It's called a tautomerization. And so basically the idea of this is the water and the carbon dioxide are very stable. And this is a less stable thing. So it just rearranges itself into two more stable components. And it does that just spontaneously. So this is the other thing you're going to have to do is basically rewrite then. Rewrite after balancing. Excuse me. So rewriting after balancing would then be meaning substitute. Substitute in the water and carbon dioxide. So I'm going to rewrite this whole thing as, it's a little extra work. Rewrite it as Na2CO3, that's the same, plus 2HCl, that's the same, goes to 2NaCl, that's the same, but instead of that, I'm going to write it as water, carbon dioxide. And then, okay, so we're still kind of finding the states. What are the states? This was aqueous, this was aqueous, those were given to me as aqueous. Water is always a liquid, carbon dioxide, just about always a gas. And sodium chloride I can look up on the table. Sodium's always soluble, it's a group 1A cation, so that's aqueous. Okay, so now I have, this is the final step of a balanced equation. Now I want to write the total ionic equation. So let's continue. This is where I'm going to break it apart. So I have 2 sodiums, 1 carbonate. So that's going to be 2. Let's move this, kind of center it. 2 sodium ions aqueous plus carbonate, 2 minus aqueous, plus looks like 2 hydrogen ions, 2H plus aqueous, 2 chloride ions, plus 2 Cl minus aqueous, that's the reactant side, goes to, this is aqueous, right? So 2 sodium plus aqueous plus 2 chloride minus aqueous plus, okay, now liquid and gas, I'm going to leave those as is. H2O liquid, CO2 gas. Whew, took the whole, so I'm writing it bigger. You guys are welcome to write it smaller, but recommend when you do the total ionic is move all the way to the left and give yourself enough room. Okay, cancel out the spectator ions. What are the spectator ions here? Anybody? What goes away?
2Na.
Good. Sodium's just floating around. It's not actually part of the reaction. What else?
Would the CO2 also go, or I guess not because of the
Oh yeah,
3?
definitely. It takes it. There, all the sodiums go. Sorry, maybe I should have better. Yeah, it would be to cross through the 2 and the sodium together. My bad. I'm going quick again. Sorry. Okay. What else?
2Cl.
Yeah. So I'm gonna let's do it the right way. I'm gonna cross out that 2 and the Cl, so there's no mistake. See that? Okay. Is there a common denominator with what's left? No. I see 1, 2, 1, 1. So I'm just going to write what's left. When a carbonate ion in solution finds 2 hydrogen ions in solution, they form water, liquid. Oh, these are aqueous, by the way. Aqueous, aqueous. They form water, liquid, and carbon dioxide gas. So this, this equation is the Alka-Seltzer equation, right? The plop, plop, fizz, fizz. Or your antacid, right? You can take Tums, which is calcium chloride, and it reacts with your stomach acid, right? If you get too much stomach acid, you get heartburn, right? So it's actually an important type of reaction to learn. Okay. So this is good. We've gone through, if you think about it at this point, what have we covered? We've covered a precipitation. We've covered neutralization with an acid base. We've also covered a gas forming. Now, technically, the gas forming, sometimes they'll also call it a neutralization because it's getting rid of an acid, right? So, you know, just a mention that you might see that when you're gas neutralization. Okay, that's what we've done. So there's a couple other cases. If you guys want me to continue practicing, I think people like seeing me do this work. Hopefully, I mean, this is the best we can do when we're shelter in place, but I could do a null set, which is important. You guys should see one of those. And if you want, I could do a really hard one. You want to see a really hard one as well?
Yes.
Okay, let me do I'm going to do the null set first. Is that okay? Because it can happen. It's important to recognize that you can have a null set. And so let me do it. Mr. Kant wants to do null set. And so my statement for null set is if everything is aqueous, comma, then everything, will cancel. And so people were asking on the lab, they're like, well, do I just leave it blank? No. So let's say don't leave it blank. There's an answer we can give. What's the answer if everything cancels? If everything cancels, the answer is you say no reaction. You specifically say there's no reaction there, right? So you could have A plus B goes to no reaction, okay? That's what I want to see, that you recognize. You don't just leave it blank, that you can show me, demonstrate that you recognize that that's not a reaction, okay? Let me do an example. How about calcium chloride with potassium nitrate? I think I did this in the lab. Is it okay if I'm repeating stuff I did in the lab? I hope you guys don't mind. Okay, so when I write this, okay, so someone wants me to go through a question from WebAssign homework. Yes, I will. Some of us only have the lecture. Yes, so that's why I'm repeating this. I think so some of you might be bored with this but that's okay. I mean, you might want to just watch it again anyways, because I think it's, anyway, so let's continue. Absolutely. Let's continue. So calcium chloride, we broke this one apart before. It's calcium 2 plus, 2 chloride minus. This is very similar to the silver nitrate. It's potassium plus and nitrate minus. When they switch partners, potassium's going to go with chloride, calcium's going to go with nitrate. So my products are calcium nitrate. This was actually from the first one, and this is a +2 and a -1, so it's got to go 2 nitrates to make a 0. And ignore the coefficient with the chloride. I have +1 and -1, and I want potassium. I want the metal first, KCl. So those are my products. And so I get to calcium chloride plus potassium nitrate goes to calcium nitrate plus potassium chloride. And then I want to balance it. If I look at this, I have, well, the metals are all one potassium on each side, 1 calcium on each side. The chlorines, 2 and 1. So I'm going to put a 2 here. And then that changes the metal. So now that I have 2 potassiums here, I'm going to want 2 potassiums over here, which that's kind of good because that gives me 2 nitrates, which balances the nitrates. Now it's balanced. Let's go to the states. So this is aqueous. This is aqueous. And then if I look at nitrate is always aqueous, no exceptions. And potassium is a group 1A cation. It's also aqueous, no exceptions. So this is my balanced equation, right? I got that far. That's finishing step 4. When I go to the total ionic equation, everything gets written as ions, right? I have calcium 2 plus aqueous. This is tedious, but I'm going to do it anyways. 2 chloride minus aqueous plus 2 potassium plus aqueous plus 2 nitrate minus aqueous goes to calcium 2 plus aqueous plus 2 nitrate minus aqueous plus 2, let me bring that up, potassium plus aqueous plus 2 chloride minus aqueous. So what cancels? What cancels? Anybody? I see calcium.
Yeah.
Calcium's
Okay.
gone. Chloride's gone.
2K.
Oh, potassium's gone. It's all gone. There's nothing left. So this is why you can think of it as a null set. So what you need to write is for your net, the answer to the net is no reaction. You can show this as your total ionic, right? You could do the balanced equation, the total ionic, but for the net, you better say no reaction because there's nothing left.
I have a question about this for the lab worksheet that we're doing. And
Yes.
it's asking us to do this. If we can just predict using the solubility table that there's going to be no reaction,
Yeah.
do we still
If
need
you
to do
guys get
all
up
this?
to here and you see aqueous, and these are aqueous, you can just say no reaction. You don't have to go through all these steps.
So, like, how about if we're using the solubility table? Do we need to even do the first step?
Yeah, if you want to, so for the lab, you can say, whatever, CaCl2 plus KNO3, no reaction, and I'll accept that. Why did Mr. Canton do all this? Well, because you can reason your way out of it. And to me, this kind of proves my case at the end. So I basically wanted to prove it to you. But yes, you can take the shortcut. I said that in the lab period too. So I'll stick by that, okay? So I hope that.
All right.
You have 9 minutes left.
I'm sorry?
You have 9 minutes.
Okay. Well, I mean, this is actually, let me stop the recording. I think this is actually a good spot here.